Okay, a minute. Give me a minute. My computer is slow. It is disabled.
Yes.
I can share my screen.
Oh,
I'm not allowed.
yes. I just update. Okay.
Okay, great.
I think you can now.
Okay. Could you see my screen?
Yes.
Okay. First question. What is one outcome or collection of outcomes called?
Mm.
Wait.
Outcome.
Okay. They gave four possibilities: sample space, event, and or tree diagram. Sample space is the universe of possibilities, so the set of possible outcomes. And an event, it is a subset of this big sample space. An action, it is a random experiment or a process that leads to one of the many possible outcomes. And the tree diagram, it is a tool that we could use to easily understand a problem and find a probability.
So,
Example,
sorry. So the answer here is, hang on, an outcome event. Yes.
yeah.
Yes, I understand this. Okay, we can move to question number 2.
Okay. Question number 2. You collect a sample space that contains all three child families according to the genders, boy or girl, of the children with respect to birth order. How many different events possible? When in this case, this is a kind of drawn from a sample. When we draw a subset of K element from a sample of n elements, to decide if it is a combination of the element or an arrangement, we try to see if the order, if there is a specific order in the element which are drawn, and if the elements are taken only one time without replacement. When there is replacement, it is a combination. When there is an order, it is an arrangement, and when there is no order, it is a combination. Now, an arrangement could be made with repetition or without repetition. And when it is with repetition, there's a formula for computing the number of possibilities, which is different from the case where there aren't any repetitions.
Okay, can you go through and explain for me, like how do you input the number, for example, like arrange with the repetition and arrange without repetition?
Okay, I guess you try to take
Like,
collect a sample.
yeah, like I'm not sure like how to input the number, so.
Okay, they say that they collect a sample which contains three child families according to the genders, boy or girl, of the children with respect to birth order. As they said, it is with respect to birth order. So the children are there is an order in the children selected. As there is an order, it is an arrangement. Secondly, you have to ask yourself if there is repetition or not.
Hang on, let me guess. So question, your collect the sample space contain all three child in the families according. So it's not repetition. So it's without repetition.
But you know, what we are trying to see here is if it is a boy or a girl, and we are
Yes.
taking three of them. So it's necessary, there is a possibility that we have two boys or two girls.
Yes. So there's.
So the elements are
Oh,
repeating.
so it's with repetition. Oh, I sorry. I got the concept, the tweet. Okay, with the repetition for sure then.
In this case, there is.
Yes.
Yeah.
Okay, so in this case, like how do you input the number in the formula?
Yeah. When there is arrangement with repetition, the number of arrangements of car objects amongst n with repetition is equal to n to power k. In our case, our n is 2.
Oh,
and our k
sorry,
is
can you help me write it down like on annotation? So can you let me show you.
yeah, I did it just below.
Oh,
Arrangement with
it's
precision
awesome.
of 3 kids. Yeah.
Yes.
Amongst there are possible sexes, which are 2, boy or girl.
Yes.
So they give 2 power 3. Got
But I see in the formula there's a 3 parameter. So
a 3 parameter.
yes. Yes.
Ouais.
So A, K, N. So what do you put for K and what do you put? Well, N is, I know already is 3. So what is, equal NK. Okay. I see.
Yeah.
So how is that formula transformed? I think I forgot the algebra. So how AKN is equal NK?
At the first, let me my. Boy or girl. I don't know how to explain it to you.
Maybe can you search for, like what would be that concept is called? Then maybe
You want the demonstration or the
so I don't
the intuition?
yes, I don't understand how AKN is equal NK. Like how do you transform it to be, where do you put the A in the right hand side?
Okay, A is just there for saying that it's an arrangement. If you notice, when it is a combination, I use a C for the notation.
Oh, so but I remember like when I was to school, like the AKN, like they all count for something, right?
Yes, it's the formula below this one. Factorial n divided by n minus k factorial.
Oh, okay. So A here it doesn't matter, right?
You see?
Oh, the A here is doesn't matter?
It matters. This is the norm. This is the normal meaning of the A and E. This is the formula. And in the case of repetition, come back to E. But for the demonstration, I have to look for it again. I don't have it in mind.
Yes. So my question is like, so this K, so how do you transform it to here? Like, I remember there's a way to transform like this number to this number. It's called logarithm or something like that. You know, like how to transform like Kn to just like Nk here. Like I remember it's the logarithm rule. It was so long ago. I couldn't recall now, but something like that. Do you?
I will look for it and tell you later.
Okay, sure, thank you. Okay, so let's move on to the next question, I guess. Thank you so much. The note is very detailed.
You're welcome. Question 3. The probability that Noya succeeds at any given free throw is 70%. He was curious how many free throws he can expect to succeed in a sample of 15 free throws. He simulated 20 samples of 15 free throws, where each free throw had a 0.7 probability of being successful. Now we are counting how many free throws were successful in each simulated sample, and here are his results. So when you take 8 free for success, on his 20 trials, only one has 8 free for success. 3 got 9 free for success, and so on. So they asked her to use this result to estimate the probability that he succeeds at greater than 10 throws in a sample of 15 free throws. So the probability that is greater than 10, it's equal to probability that it is equal to 11 success, 12, plus the probability that is equal to 12, plus the probability that is equal to 13, plus the probability that is equal to 14. Do you agree?
Hang on. The probability he success how many free flows. So so to calculate this, we use I'm not understand. Can you a notation tool to mark down?
Yeah, this year the probability that is greater than 10, make the probability that is equal to 11 plus the probability that is equal to 12, 13, 14, and 15. This sum. Do you agree?
Hang on. Oh, so this is the one without without repetition, right?
Here.
We move to a.
There is no repetition.
Oh, okay.
Like.
Hang on. Let me go back to the notebook. I'm a little lost on this. Okay. Oh, hang on. Can you move up a little bit, please? I think during when you send me the notebook, the pictures is missing. So let me reread. The probability of NASA succeed at any given free flows is 70%. How many free flows? 20 sample, 15. Okay. Sorry, can you help me re-explain it for me, please?
The exercise, the question.
Can you help me like re-explain the concept for me, please? I think I'm lost.
The question or the concept, the theory behind?
Oh, I think I understand the question. I don't understand the concept, how you calculate to that number.
Okay. If it was just one sample of free throws, or 15 free throws, it wasn't pointy. You should think that to be a binomial distribution, because there we take a random variable x, and we say that if follow this a binomial distribution, when to compute the probability, you use this formula. If we take an event and it is a success, it get big success and n minus x failures, where P is the probability of success and Q is death. We say that it's a binomial distribution. In our case, when we take here the ball and he makes 1 free throw, either he gets into the basket or he gets out of the basket. If he gets in, it's a success. If he gets out, it's a failure. And they gave us the probability for success, which is 0.7, and the failure, we can guess it. So, and he repeated 15 times. The random variable associated to the number of trials, the 15 trials, follow a binomial law of parameters n equals 15 and p equals 0.7. And for, do you understand it?
No, I'm lost. Hang on, let me read it. Okay, hang on, let me read it. Binomial distribution, random variables follows. Oh. Even events comprise of X success and Q. So why Q is equal 1 minus P? What is Q and what is P? Oh, P is probability. Okay. 1 minus probability is equal Q. So Q is the value, right?
Yeah, you're right.
Okay.
There are only two possibilities, success or failure.
Okay. Sure. I got it. The binomial distribution with parameter N and P denote B and P is discrete. Oh, so what is the difference between the binomial distribution and discrete probability distribution?
A binomial distribution, this is an example of a discrete probability distribution. When you take care of the binomial distribution, you got the probability, the same thing. You got the probability on the y-axis, and on the x-axis, you got the number of success.
So these two are the same?
The binomial distribution is a case of discrete probability distribution.
Oh, okay.
There are discrete and continuous distribution.
Okay.
When you take discrete, there is the binomial one and others one, like exponential.
Okay. So in other terms, the binomial distribution is a part of discrete probability distribution, right?
Yeah, you get it.
Okay, I got it. Okay, so let me have a look more. Okay, let's see the answer. I got it now. So Px smaller than 10. Hang on, so why is this smaller than 10? I forgot the question already. Oh, could you move to the full next one so I can see the question, please?
Probability greater than 10 successes.
Oh, okay. Hang on. So
this question, they are asking you the probability that he got more than 30 successes after the 20 samples of 15 free throws. He made one sample of 15 free throws. Two samples until 20. If it was only one sample,
so,
the answer will be that one.
Yes, but so why there's a 20 there? Because I see that he only throw 15 times, right? Why he need to generate 20 times?
I don't know how to. When he start, he make 51, and at the end he count the number of success. He did again 51 until to reach 20. And if you see the here, if you count the number of points on this graph, you will see that they sum up to 20. They sum up to 20.
Oh, hang on. Maybe I misunderstood something. Okay, the probability of now your success at given throw is 70%. Okay, I got this. He was curious how many free throw he can expect to succeed. The table of 15 free flows. Okay, what does it mean? What does it mean by free throws?
By free throws, when you play basketball, there is a line where you could shoot and you get 1 point. Once a player make a fault, you should make a shoot. It is called free throw.
Oh, okay. So basically, it like between 15 free flows, how many it makes to the basket, right?
Yes. How many get to the basket?
Yes, the language. Small details make me confused. He simulate 20 sample of 15 free flows. So that means like 20 samples. Is that mean like he throw 15 times or he like just try 20 times?
No, he tries 20 times 54 rows. First try, he make 50. He count the number of success and he records it. For example, if it was 8 success, this is the first point there. Then he makes again 54 rows. If it is 9 success, he adds a point at the on the graph.
Can you draw it out? I'm a little bit confused. Can you use the annotate tool to draw it out? There's an annotate tool.
Okay.
Yes. Yeah, so
sample 1. Sample 2.
Oh, okay. So those are the sample. Okay. So in each sample, it has many throw, right? Each sample have 15 throw, right?
Yes.
Ah, okay. Oh, okay. Where each tree? Where each row has. Okay, so each sample they have 15 free flow, and each of the 15 free flow has 0.7% of success. So they ask how many flows were success in each stimulate result.
Yeah.
Okay. I understand.
Okay. Now they are asking you what's the probability that he got more than 10 successes? So it makes, here you see, there is 3 cases where he get 10 successes over the 20. Here there is 5 cases where he get 11 successes over the 20 samples. There is 5 cases where he got 12 successes. So the probability that he got more than 10 successes, it makes that the number of cases where he got 11 successes divided by the number of trials plus the number of cases where he get 12 successes divided by the number of trials plus the number of cases where he get 13 successes divided by the number of trials plus the number of cases where he get 14 successes divided by the number of trials. If there were another case, you will take the value and add it up. I don't know if you get it.
Can I see the questions? Can I see the formula again?
The formula. Here there is no formula. The formula was the case if there were only 1 sample, but there is 15 samples. So what you should use it is this picture, this plot. You count the number of cases where there is more than 10 successes, and you divide it by the number of trials. Over the 20 trials, in how many cases he got more than 10 successes?
Sorry to bother you again. Can you help me? Annotate it out so I can see better?
Okay, wait a minute.
It's in the map, in the draw. Yes.
I'm more at my ease with my keyboard. Do you know how many trials did he do?
So he have 20 trial.
Yeah.
Yes. 20 trial. Yes.
And over the 20 trials, in how many cases he got more than 10 success?
How do we know that?
Yeah. Here.
Oh, okay.
There is 1 case where he got 8 success. 3 cases where he got 9 success. If you make the sum, you will get 20.
Okay, I see. Oh, so you have to base on the chat. Okay.
Yeah.
Okay, I see. Okay, so basically, for number of a success. Oh, okay. So hang on. We need to count the sample of 15 success, right? Or 70% success? So
No, try to forget about the 15 free falls, the 17%. Just focus on the plot. In how many cases he got more than 10 successes?
4 case, 11, 12, 13, 14.
Okay, you got it. Now try to make the sum of these cases.
Okay, so let me see 11. So 11, we have 1, 2, 3, 4, 5, right? 12
5
is
samples.
so 5, 5, 10, and 13 is 2, and 14 is 1. So it's the 13 over 20.
13 over 20. This is your probability. You should got 0.65.
Oh, okay.
Yeah. What I did here, it was just to make theory. This was going to be useful if you had this plot, and if it was only one sample, he did one sample of these different force. You should do as I did in the notebook.
Oh, you need to click on the mouse, yes.
Do what? You said what?
No. Oh,
Okay. Yeah, you had to do all this process. It was only one sample of 53 force.
Oh, okay.
And I said later that as is not the case, you should do like this. You make the sum, you divide by 20, and you got your result.
Oh, okay. Yes, I got it. So let's go on the question 4.
Okay. A middle school principal has 80 Ks on her kitchen to distribute to staff on the first day of school. Of these 80 Ks, 60 open classroom doors, 40 open the door of the teacher's lounge, and 30 open classroom doors in the teacher's lounge. Using this information, answer each of the following questions. Let's say the event, a randomly selected K opens a classroom, and T be the event that a randomly selected K opens the teacher's lounge. What is the probability of C of T? The probability that a K opens a classroom or the teacher's lounge.
Hang on, let me read. A middle school principal of 80 keys on her train. Okay, yes, I read this. So, okay, I understand the first line. So P of C of T. Okay, I remember I saw this one. I was solving this one. P, C, P, probably C belong to T. Okay, yes, I got this. So 60 divided by 80 is 0.75. Hang on, what is the 60? Okay, 60 is open classroom door. Okay, so so 0.5 is PC. Yes. Okay, PT. Okay, I got that. PC and T is oh BC and T. No, BC and T is neither C or T. Okay.
You got it?
Yeah, I got it. Yes, I got it.
Okay,
So
great.
yeah, question 5. Is blue and green. He has one blue shirt and one green shirt. One blue hat, one green belt, one blue pair of pants, one green pair of pants. Event has one blue shirt, one green shirt, one blue hat, one green belt, one blue pair of pants, one green pair of pants. Probability of A or B is okay. So it's similar to the one above, right?
Yeah.
Yeah.
Somehow.
So I got it. Yes.
Okay. Right.
Yeah, I think I got this question. Yeah.
Ask a people
Oh, it's the same with the above, right? Hang on, let me read to just make sure. Um, oh, okay. So agree or neutral. So yes, I got this one. Okay,
Okay.
the one up below that is the one that I don't get. The question 7.
Okay. Probability of a couple having at least one boy among 4 children. If you consider, you let X be the random variable associated to the event, a couple got a certain number of boys among his children, where that is greater than 1, it's equal to probability, it's equal 1 minus the probability that he got no boys among his 4 children. And if he got no boy, it is equivalent to the event where he got 4 girls children. And the probability to have 4 girls, yeah, it is the first child is either a boy or a girl. So it is 1/2. The second child also, the probability to get a girl is 1/2. The third and the fourth. So the intersection of these 4 events, it is 1/2 times 1/2 times 1/2 4 times. So it's 1/2 at power 4. So 1 minus that probability, we got 15 divided by 16. What is approximately 0.94.
Hang on. I'm a little bit too bit confused. So for the probability of couple have at least one boy amongst 4 children, okay, P x more than 1 is Px minus x equals 0. So that means like minus the probability of having no children, right? X equals 0.
No boy children. No boy children.
Pardon?
1 minus the probability to have no boy children.
Yes. So have
no boy amongst the 4 children.
okay. Oh, x equals 0. That means like having no children, right?
No. X is the number of boys amongst the 4 children.
Oh, okay. So this is the probability of having no boys.
Yeah.
Okay. So 1 minus P O of children are girls. Oh, okay. So you explained to me that. Oh, I'm so serious. Yeah. Okay. So equal 1 minus 1/2 over 4. So why is it 1/2 over 4?
Yeah, because when you take when a child born, either it is a girl, either it is a boy. So there are 2 cases, it is 1/2. The probability to have a boy, to have a girl, it is 1/2. And we repeat it 4 times for the 4 children. It is an intersection of the event that the first child is a girl, the second one a girl, the third one a girl, the fourth one also. So we make the product of probabilities.
Hang on, let me see. So 1/2. I'm still a little bit confused of 1/2 power 4. So how do you get that one? Could you help me write it down?
Okay.
Yeah, this one. I'm confused. Like, how did you get this number?
At the birth, either he got a boy, either they get a girl. And the probability to get a boy is 1/2.
Oh, okay.
To get a girl,
Yes.
this is
Yeah, I
1/2.
got it. Yes.
Now, we are in the case that they got a girl. The second child is also a girl. The second child, the third one is also a girl. The fourth one is also a girl.
Mm-hmm.
So it makes 1.5 times 1.5 times 1.5 times 1.5. And you got 1.5 power 4.
Yes, I got it.
Okay. Okay. You can move to the next question.
Yes.
Okay. Question 8. A business owner noted the features of the 100 cars parked at the business. Here are the results. There are 3 sets. A set of cars with sunroof, set of cars with 2 doors, set of cars with 4 doors. And there's an intersection with these sets. They asked her to find the probability that a randomly selected car from this sample had 2 doors or 4 doors. Okay. I define X as the random variable associated to the number of doors of a car. And now it has to compute the probability that is equals to 2 or it is equals to 4. So it is equals to the probability that X equals 2 plus probability that X equals 4 minus the intersection of the two sets. Probability that is equal to and X equals 4.
Sorry, let me double check again. I'm a little bit lost. So a business owner note a feature of 100 car park at the business. Okay, find the probably random select car from this sample have 2 doors and 4 doors. Okay, so 2 doors is 14 total, right? And 4 doors is 25 totals. So
No,
no?
it is 20. $2 is 14 plus 18.
Oh,
And $2 25 plus 20.
oh, okay, I see. Okay. So for the probability of select car from this sample had 2 doors or 4 doors. So it's basically like either this or this. Okay. Oh, let me try. I think I got it. So we need to find P4 P2 oh, I have P2 or P4, right? So we need to find this P2 or P4. So hang on. So we need one. First, we need one, and we subtract the sunproof one. So so we just need one. We subtract this, and we will get the number of P2 or 4, right? So it's the 1 minus. Oh, so there's a 10. So these 10 have no door.
When they gave you this kind of probability of a union of events, when it is a union, you should take the probability that the first event occurs plus the probability that the second event occurs. And when you make this sum, if there is an intersection, this part is counted 2 times in this probability. So you should withdraw. So you should subtract the probability that this event occurs 1 time to
Oh,
measure
okay,
the
I see.
right probability. Yeah.
Yes, that is much faster than subtract all of the other the stuff. Yeah, I got it. Yes.
Okay.
So it depends on the question, right? Sometimes you have to like get a total and then you subtract the one that's not happening. Sometimes you just plus 2 event together.
Yeah, it is a union. If you are this space, for in this case, you are in this space. Either it is 2, either it is 4. So it is this space. If the question was asking you, for example, the probability that the car doesn't get 2 doors. So the contrary set to this one is this space. So it will be 1 minus the probability that a car is in this set.
Okay.
Yeah.
Okay, understand. Okay, we
So
can
now,
go to the next question.
okay. Ninth question. Justin lives in St. Paul and goes to school in Minneapolis. In the morning, he has 333 transportation options: bus, cab, or train to school. And in the evening, he has the same 333 choices for his trip home. If Justin randomly chooses his ride in the morning and in the evening, what is the probability that he'll use both the bus and the train? I define A as the event associated with the fact that Justin used the bus, and B, the one associated with the fact that he
Sorry.
used the train.
Yeah, sorry. I have a phone number. I have a phone. Let me listen to it real quick.
Okay.
Okay, I'm back. Please continue.
Okay. So they are asking us if he chose randomly a ride in the morning and the evening, what is the probability that he used both the bus and the train? A is the event where he used the bus, and B is the event where Justin used a train. So they are asking us the probability that he used at the same time the bus and the train. There are two cases. Either he used the bus in the morning and the train in the evening, or he used the train in the morning and the bus in the evening.
Oh, okay. So hang on, let me try what you just taught me to see if I can get this.
Okay.
Because I think this question is repeating a little bit. So let me try from the start. 33 series transport. So our total is 33. So our one is 33, right?
Don't refer to the 33. Refer to the number of possibilities. There are three possibilities. Either it is a bus, a cab, or a train.
Yes. And in the evening, he has the same choice. Oh, okay. So total is 33 times 2 if the random ride in the evening. Use both bus and train. Okay, so bus, car, train. So is it 3? So each time he has the choice of 3. We can only go by bus or by car or by train. So in the morning is 1 time 3, right? In the afternoon, in the evening, it's the same. Okay. He used both. So, but then each time he only can select either a bus or the train. Like in the morning, he can only go by bus or by train. He cannot like bus and train, right?
For the day they are asking you the combination of morning and evening. Take a bus. He will take a bus in the morning and a train in the evening.
Oh, if he use both bus and train, that means like in the morning he can go by bus or train.
Yeah.
And in the afternoon, he can also go by bus and train, right? Sorry, someone call me again. Give me a minute.
Okay.
Hello? Okay. So, okay. Yeah, I see. I understand now. So it's, yeah, okay. Okay, yes, I understand this one. Okay,
Okay, great.
yes, so I start getting this. Thank you so much
Okay,
for helping. I think I start
you're
getting
welcome.
it's clear. Okay,
Right.
so let me try question 10. Your friend told you about someone really smart who made a deal with the bank, who know everything. Which of is more likely? Your friend told you about someone really smart who make a good deal with a bank. Your friend talk about the man with the job. Hmm. Good deal with a bank regarding friend told you about someone really smart who made a good deal with the bank. Yeah, the statement two is doesn't mention anything about the job, right?
No.
Yeah, so statement one, okay. I think I got it. We can move to the next quiz. Thank you so much for the explanation on this slide. It's very thoroughly.
You're welcome.
By
Okay.
the way,
The next,
how do you type this letter? Like how do you type this letter?
I use Markdown and LaTeX.
Can you show me how to do this?
Uh, for the LaTeX, you should use
Oh, you know latex?
a little bit.
Oh, can you show me how to? Because I'm still learning latex also, and a lot of things that I don't get it. So maybe we can have like one session on latex. Is that all right?
Okay, I'll try to make a notebook for that.
Oh, awesome. Oh, we can do live a session. I'll send you what I'm trying to do, and you can show me on the session. So you know
Okay, great.
everything. So yes, and I also want to like know how to write down these stuff. So not instantly, but maybe sometimes. Let me make a schedule for it. Else I forget. So on at at the like around 16 to 22. So 2 more weeks from now, could you help me show me how the latex work?
Okay, great.
Awesome. Yes, awesome. Thank you so much. So let's move on to our next question. Yeah, I'm also
Next
editing my
quiz.
CV on latex, and it's such a mess. Yeah, I think I made something wrong, but I don't have time to fix it. So I really want to know how to learn how to do latex coding.
Okay, I see.
Okay, let's move on.
Which quiz should
Okay, so there's another quiz, right?
yes? My computer is slow.
Oh, okay.
Maybe. Okay. There were the quiz 11, 12. Maybe the 12, we didn't solve it. Yeah, we did it the first time, this one.
Oh, we did this one the first time?
Yeah, the 11 one.
Oh, okay. Did we finish it?
Yes. It
Oh,
was the 12 we didn't do.
oh,
I
okay.
think. Yeah, we didn't do this one.
Okay. Sorry, let me go back to the 11. For some reason, I don't remember we solved it yet. Let me double check just to be sure. Okay, yes, you are correct. I have such a goldfish memory. Oh gosh. So yes, you are correct. Let's go for that. Let's
Okay.
go for this one. Yes. Oh, actually, let me try to solve this because I solved it once and I don't know why it just disappeared. So
Okay.
let me try to solve this to see. Okay. Ice cream shop from working easily in different flavors. Okay. Oh, so can you scroll it down a little bit so that I can see?
Okay, I'm coming. So, okay. Question 14.
Mm. Oh, okay. So we basically have like this one is type of table. So you need to time it. So 4 times 0.5, something like that. Okay. In the following table, what did it mean of flavors? What does it mean? What is mean amount of flavor in
Mean amount of flavors.
So 1, 2, 3, 4. So we have 4 flavor,
Yeah.
different flavor.
The amount of flavors is the probability for the flavor.
Yeah, I don't understand the question. Could you help me explain for it?
I think that they said that the ice cream shop has problem with delivery of the different flavors. As a consequence, the shop doesn't have the same amount of flavors every day. In the following table, you see the probability distribution of the different amounts of flavors. 4, 5, 6, 7 are the amount of flavors. Now the probability to have an amount of flavor of 4 is 0.15. Right, to have one of 5 is 0.30, one of 6 is 0.30, and one of 7 is 0.25. And they ask you for the mean. The mean is the same thing that as than the mathematical expectation. And to compute this one, you should just have to take the discrete value times its probability.
Oh, okay.
Discrete value times the probability, and you make the sum to get the
Oh,
mean.
okay. Yes. Okay, I got it. So basically, what is the mean amount? Oh, okay, the mean amount. So the mean is basically you make a sum and then you divide by 4, right?
No, there they gave you already the probability. You don't need to divide by anything.
Oh, okay.
So
So
they
it's
have to
already
make
the
the
mean.
sum. Yeah.
Oh, okay. So for example, the mean of having 4 flavor it is, the mean of having 5 flavor it is. So they ask what is the mean amount. Oh, okay, I got it. Okay. Yeah, okay, I got it now. Okay, question 2.
I have tried to make the computation to see if it gives the result.
Yes.
Have you tried the
yes.
computation?
Yes. Okay. Let me try. It's now. So let me. Yes. Let's use the notebook to see. Can you help me control the notebook to make the sum to see? So for
Yeah.
0.15 plus 5 times 0.20 plus 6 times 0.30 plus 7 times 0.725. No, no, 7 times, no, go back, please. So 7 times 0.25.
15 30,
Yes.
30, okay,
6,
25.
30, 25, yes. Oh, typo.
Yeah. Okay, give you a result.
Yes, I see. Okay, let's go to the next question.
Which of the following statements is correct? 1. A discrete random variable can take a finite number of distinct values. Height, as measured in centimeter, is an example of a discrete random variable. Statement 2 is true. Statement 1 is false. Both statements are true. Both statements are false. Statement 1 is true. Statement 2 is false. Why? Sorry.
So, okay, can you move up a little bit? I think, okay. Which one? A discrete random variable can take finite number of discrete values. High is discrete is so statement 2 is not correct because high is high could be the example of discrete random variable finite number. So both 1 and 2 are correct. Oh, statement 2 is false. So discrete is, it means like it doesn't have anything related to one another, right?
What kind of variable is height?
Is discrete, which kind of variable discrete? It doesn't.
No, it's height, the height. Is it a discrete or a continuous random variable?
Oh, okay. So height is continuous. Oh, yes,
Okay.
because you only have you cannot have like 3 meter and 50 centimeter, right? This has to be like a continuous within a range. Okay, I got it. Okay.
You can get decimal values for the height. Okay.
Yes. Okay.
Question number 3.
Okay, question number 3. Researcher is interested in the time people spend online and social media per day. She plot the probability distribution for this variable using our unit test below. She decided to measure the time instead of the hour. Okay, yes, I got this. Yes, I got it, this one.
Okay.
Okay, consider the following discrete probability distribution. What is the probability of x being lower or equal to 3? Okay, so let me try this one. I think I got this. Annotate. So these are the probability of lower than 3 equal. Oh, so this one. So it would be 1 times 0.20 plus 2 times 0.33 plus 3 times 0.06, right?
No, here you don't have to multiply it by the discrete value. Here you just have to make the sum of the probabilities. It is a union and the events are independent. There are no intersections. Either it is 1, either it is 2, either it is 3.
Yes, but it said like being lower or equal 3. So, we only get this line up, right? We doesn't get this down here. 4, 5, we're not gonna get it. We just get
You
this
got
one.
it. You are right. You are all completely right. But they ask you the probability, not the mean. And when it is the probability, you just have to make the sum of the probabilities.
Oh, okay. So, oh, this is x. Okay, so I only need like 0.22 time plus 0.33 plus 0.06, right?
Right.
Oh, so why don't we regard this? Sorry, can you move up a little bit? So let me clear all the drawings. So why don't we attempt this? Oh, because we don't calculate the mean, right?
Yeah, yeah. This
Ah,
is the
okay, got
probability
it.
of computing.
Okay, let's go to question 5. Uh, your inve- your investigate the number of earthquakes that occur in a year. You get the following outcome. Number of earthquake. What is the variance to this? Oh, okay. So we have to calculate. We have to use the variance. You have to use the variance method, right?
What is the variance of this random phenomenon into this Yeah, you have to use the variance.
Okay.
And for computing the variance, remember the formula.
Yes, I have it here. Let me have a look of it. I remember it's something like this. Let me try to call it for my memory first, and if it's incorrect, then you can help me out a little bit. I think it will help me to remember. So it is oh god, it is something about like S2 is equal um hang on x square. Okay, let me try. So I remember something like x square minus mean divide by times, like the time is row, right? Is it the correct one? Yeah, just either yes or no, then I'll try to think a little bit more, a few minutes more. Is
You
it?
subtract the mean to each observation and we divide by the
Yes, x.
standard deviation, and we take the root, the power 2, and we make the sum for all the observation.
So
This
this
is
one is not correct.
no, it's not.
Oh, I thought it's the formula for variance. Hang on, let me double check on one. Oh, okay. How about this one? Hang on, don't give me answer yet. So let's
Okay.
try this one. So something like this. Because I'm looking at the chat that I have chat with us, the teacher assistant in the class from the channel. So we have this formula, and then we have let me have a look of the chat that I had discussed about this one. Yeah, the thing about me is like I have been doing this for like a few times already.
This one, it is right if the mean is not known, if the
Hang
mean
on.
is as known. But if you know the mean, you divide by n.
So how about this one? Is this also the formula? This one.
You should subtract the mean. Subtract the mean.
Can you like explain for me like this thing again, because I don't know how to get like variance and normal distribution.
Okay.
Yes.
There are, for computing the mean, either for computing the variance, either you know the mean or you don't know it. So when you don't know the mean, you compute a sample mean. You name it x bar.
Mm.
And when you use it in the formula for computing the variance, this is the formula.
Mm-hmm.
divided
Okay.
by n. We assume that we know the mean, so it is x minus the mean that we know, well 2. Now, when we don't know the mean, we remove this one and we use the sample mean. We use this one, x bar. And when we use the sample mean, this is an estimated value. We should subtract, as it is only one estimated value, we subtract 1 here. For that it stays on yes and best layer on yes estimator. For that it converges to the real value of the variance. There is a way to demonstrate it, but I don't think it's useful. You just have to remember that when you know the mean, you put the real value of the mean and you divide by n. And when the mean is estimated, you have to subtract 1 degree of freedom here at the denominator.
Hang on. Mac, can I have a request? Can you help me like put this in the notebook tomorrow? I'm very confused about the different formula with variance. Like every time when I revisit it and then I don't get it, and it has been like several times already. So can you help me like you did what is the probability one?
Okay, sure.
Yeah. So, you know, like just because I'm still confused, like, so from what I remember here, let me show you the last time when I chat with the teacher assistant. So, so from what I understand, there's formula that I now I forgot like which one is which and how to apply it. So this one, x minus u time n, right? So this one is 1, and so I understand this also the variance, right? This also the formula.
It's the population variance.
Oh, population variance. Okay.
The one you wrote before, S power 2, it is the sample variance.
Oh, okay, I see. So there is one, the population variance and the sample variance. Okay.
Yeah.
So what is the difference between the population variance and the sample variance?
In the sample variance, we don't know the mean generally, so we use the mean of the sample. And as it's an estimated.
So in the population variance, you don't know the mean. So
in the population variance, we know the mean.
Oh, okay, you know the mean. Okay, so this one population.
Mu.
Okay, so you know, and in the other one I wrote, you don't know the mean, so that's why you minus 1 here.
Yeah, and instead of writing mu, we use x bar.